Hey learners, this is Dr. Rishi from the Learners Academy, and today we are going to solve some numerical examples from the topic work, energy and power. We have already done videos that described this topic theoretically in the past. The links for the same videos is given in the description box. If you have any queries, you can go to those links and check them out. So without losing any time, let's go ahead and check out these examples. So the first example that we have for conservation of energy is a ball of mass 50 grams is thrown vertically upwards with initial velocity 20 meters per second. We have to calculate the initial kinetic energy to the ball, the maximum height reached if air friction is neglected, and the maximum height reached if 40% of the energy is lost against the air friction. Now here they are asking us to take g is equal to 10 meters per second. So let us quickly go ahead and check this out. So first we have to find is the initial kinetic energy of the ball. Okay, so here the mass of the ball is 50 grams. So first, now here they've done a pretty complicated thing for us, that is the velocity is given in meters per second, which is SI unit, and the mass is given in grams, which is the CGS unit. So first thing is we need to either convert everything into a CGS or everything into SI. So it's easier to convert everything, all the quantities into SI unit and then deal with them. So first we take mass is equal to 50 grams, so that is 0.05 kilograms. Initial velocity is 20 meters per second and acceleration due to gravity is 10 meters per second. Now initial kinetic energy imparted to the ball. So this is the energy imparted basically means that what is the energy that is given to the ball. So we know that the kinetic energy's formula is half mu square, so we write it as half times 0.05 times 20 square, which comes out to be 10 joules. So this was our first part. So this is the energy that is given to the ball. Now the next part we have is if the air friction is neglected, then the potential energy at the maximum height is equal to the initial kinetic energy. So mgh is equal to half mv square, or we can say that h is equal to v square upon 2g, because when this m and g go towards the denominator here, m's would get cancelled and we'll get only v square upon 2g. So that is 20 square upon 2 times 10, so which would be 20 meters. So this would be the maximum height that the ball would be going if there is no air friction. Now what happens when the air friction consumes 40% of the initial energy? Yes, so 40% of the energy is lost against the air friction. So now what happens? So if the 40% of the energy is lost against the air friction, then we get potential energy at maximum height would be 60%. 100 minus 40, so that is 60% of the initial kinetic energy. So it would be 60 upon 100 times initial kinetic energy. So we get mgh is equal to, so we do the same thing that we did in the previous case, however multiplied by the factor of 60 upon 100, giving me the final answer as 12 meters as the height. So you see, if there is no air resistance or no air friction, then the ball can go to a higher level. Now let's go ahead and talk about solved examples. This is the third solved example that is there in the book. So we have a simple pendulum which oscillates, rises to the maximum vertical height of 5 centimeters from its rest position. When it reaches to its extreme position on one side. Now if the mass of the bob of the simple pendulum is 500 grams and g is 10 meters per second square, we have to find the total energy. First thing we have to find is the total energy of the simple pendulum at any instant, and second is velocity of the bob at the mean position. Now as discussed in the theory part, we know that the bob would have maximum velocity at the mean position. So effectively they're asking us, this question can be rephrased as find the maximum velocity that it can reach. So this is another way of asking the same question. So please keep it in mind. Whenever they are going to ask you for maximum velocity, they are either going to ask you for maximum velocity or velocity of the bob at mean position. And then they're also asking us what is the assumption that we've made. Now, this is a theoretical part of this question. So assumption, the only assumption that we are going to make here is that air resistance is negligible. So now let's go ahead. So we get H is equal to 5 centimeters. Again, we have to check the units. So you see the height is given in centimeters, mass is given in grams. However, acceleration due to gravity is given in meters per second square. Since acceleration due to gravity is my basic unit, I would consider to convert everything into the SI unit. So I take H is equal to 5 centimeters, so that would be 0.05 meters. Mass is 500 grams, so that would be 5.5 kilograms. And G is 10 meters per second square. Now, first we check out the assumption. What was the assumption? I had already told you that the assumption that we would be making is there is no air resistance or there is no air friction. Or in other words, there is no loss of energy due to air friction. Now, so total energy is equal to what? That is equal to potential energy at its extreme position is my total energy. So it is mgh, because we have a pendulum like this and it's going to a point here. So the bob is going here, and the height, this height is given as 5 centimeters. Okay, so at this point the total energy would be because of the height of the bob from the ground level. So that would be 0.5 times 10 times 0.05, giving me 0.25 joules as my total energy. So total energy of any pendulum remains the same throughout. So the total energy is going to be same. You don't have to worry about it. So 0.25 joules would be the total energy, and it would be exactly the same everywhere. The second part is kinetic energy at the mean position. Now kinetic energy at the mean position is equal to potential energy at the extreme position. So you get half mv square is equal to mg. M's can be cancelled on both the sides. This 2 goes on the other side, and we take root on both the sides. We get v is equal to root of gh. So that is 2 times 10 times 0.05. So that is root 1. So we get our velocity as 1 meters per second. So now let's go ahead with the next question that is there. This is from exercise 2C. This is question number 3. The question tells us that a stone of mass 500 grams is thrown vertically upwards with the velocity of 15 meters per second. Again, crucial thing to remember, mass is given in grams and velocity is given in meters per second. So we would have to convert our mass into the SI units. So we have potential, we have to find the potential energy at the greatest height, the kinetic energy on reaching the ground, and the total energy at its halfway point. So let us check. First we have potential energy at the greatest height is equal to initial kinetic energy. So mgh would be equal to half mv square. We know the value of m, we know the value of v. We put in these values and we end up getting 56.25 joules as our answer. Now, kinetic energy on reaching the ground is equal to potential energy at the greatest height. So it would be equal to 56.25 joules. And our total energy at its halfway point would be half of the kinetic energy plus the potential energy, that is equal to the total energy. So it would actually be equal to the total energy only. So wherever you take the total energy would be average of these two, and it would add up to 56.25 joules, because for any pendulum the total energy would always remain the same. Let us go ahead with the next example that is there. This is example number 4 that we have. In example number 4, they are telling us diagram given below shows a ski jump. Now this is a very interesting thing that we have. We have a skier. He goes from here and does a jump like this. He slides like this and does a jump like this. The skier weighing 60 kilogram force stands at point A, and at the top of the ski jump, he moves from point A to B and takes off for his jump at B. Now, we have to calculate the change in gravitational potential energy of the skier between point A and point B. So, point A is at 75 meters height, point B is at 50 meters height. So, 60 meters का difference है दोनों में. Now 75% of the energy in part A becomes kinetic energy at B. So calculate the speed at which the sphere arrives at point B. Here gravitation, they've given it as 10 meters per second square. So let us quickly see what we have. We have mass of the sphere is 60 kilograms, so loss of potential energy. Now here there is a loss of potential energy between this point and this point. As studied previously, the formula for loss of potential energy is when we go from a higher height to a lower height is mg times h1 minus h2. So it gives us 60 multiplied by 10 multiplied by 75 minus 15, giving the final answer as 3.6 times 10 to the power of 4 joules. Now for part B, kinetic energy at point B is 75% of our total energy. So this is our total energy that we have. So this is the total energy loss that we've had. So total energy would be lost is 75% of this energy, comes out to be 27,000 joules or 2.7 times 10 to the power of 4 joules. Now kinetic energy is half mv square. We know how much the kinetic energy is at point B. The kinetic energy that the sphere has is 27,000 joules, and it should be equal to half mv square. So it becomes 27,000 is equal to half mv square. So that is 27,000 times half times 60 times v square. So we can get the value of v square as 900 or value of v as 30 meters per second. So this is the velocity at which the sphere would be arriving at this point. The next thing that we have is about a hydroelectric power station. It takes its water from the lake whose water level is 50 meters above the turbine. Assuming an overall efficiency of 40%, now here you see our hydroelectric power plant is working only at 40% efficiency. That is 40% of the energy is actually used. So calculate the mass of water which must flow through the turbine each second to produce output of 1 megavolt. So we have an output of 1 megavolt to be produced. So potential energy is mgh, efficiency is 40%. So useful work done would be 40% of the potential energy. So that would be 40 upon 100 times mgh. So that is 0.4 times m times 10 times 50. So that comes to be 200 m. Now power is equal to work done per second. 1 megawatt is equal to 200 times mass of the water flowing each second. We figured it out from here. Yeah. So my bad, here it should be megawatt and not megavolt. Yeah. So it comes to be 1 times 10 to the power of 6 watt is equal to 200 times mass of the water flowing in each second. So mass of the water flowing would be so you take this 200 on the other side and we end up with 1 times 10 to the power of 6 upon 200, that would be 5,000 kilograms. So this is the amount of water that needs to flow every second to produce 1 megawatt energy. So let's go ahead with the next thing that we have. We have a bob and a simple pendulum. We have a bob of a simple pendulum and it imparts a velocity of 5 meters per second. Now when it is at its resting position, now to what maximum vertical height will it rise on reaching its extreme position if 60% of its energy is lost in overcoming the friction of air? Now majority of these examples are having the efficiency given, so this does complicate. These are the complicated sums as compared to if we are neglecting the air friction. So what they are telling us, we have a pendulum like this, a bob is here, we are giving it a velocity of 5 meters per second and it moves like this to a height here somewhere, which is at a height h from this level. Okay, so let's see what we have. Potential energy at the extreme position is equal to 40% of the potential energy at the resting position. So we get mgh is equal to 40 upon 100 times half mv square, or we can say that 40 upon 100 times half mv square is equal to mgh, or we can say that 0.4 times 0.5 times m times v square is equal to mgh, or we can say that 0.2 times v square is equal to 10 times h. Now here v is given to us, that is 5 meters per second, so we put in the value of v here, giving us the height as 5 upon 10, because effectively what is going to happen, so 10h is equal to 5 meters, so h would be equal to 5 upon 10 meters, so that's 0.5 meters. So this height would be 0.5 meters, that's like 50 centimeters. That seems to be a pretty large pendulum. So learners, these were the numerical examples that have been given in Concise Selina textbook for 10th ICSE. I have tried to solve majority of these sums which I found were important according to your exam perspective. Apart from these, if you have any other queries, please feel free to comment them in the comment section. I would be glad to help you out. If you found this video interesting, please give us a thumbs up, share it with your friends, and subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.